Hello all, welcome to my YouTube channel. I am Swetha, currently pursuing BA Computer Science Engineering in Sethu Institute of Technology. I have been given a topic Hadoop in Big Data to create a seminar video. Let's get into the topic. At the end of this tutorial, you will come to know about what is big data, application of big data, what is Hadoop, subprojects of Hadoop, Hadoop architecture, topology in Hadoop, features of Hadoop. What is big data? Big data is a collection of data that is huge in volume yet growing exponentially with time. It is a data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. Big data is also a data with but huge size. Following are some of the applied areas of big data: banking and securities, communication, media and entertainment, healthcare providers, education, manufacturing and natural resources, government, insurance. Now, what is Hadoop? Apache Hadoop is an open source software framework used to develop data processing applications which are executed in a distributed computing environment. Applications built using Hadoop or run on large datasets distributed across clusters of commodity computers. Computers are cheap and widely available. These are mainly useful for achieving greater computational power at low cost. Similar to data residing in a local file system of a personal computer system, in Hadoop, data resides in a distributed file system which is called as Hadoop Distributed File System. The processing model is based on data locality concept wherein computational logic is sent to cluster nodes containing data. This computational logic is nothing but a compiled version of a program written in a high level language such as Java. Such a program process data stored in Hadoop HDFS. Apache Hadoop consists of two subprojects. One is Hadoop Map Project, another one is HDFS. Hadoop MapReduce. MapReduce is a computational model and software framework for writing applications which are run on Hadoop. These MapReduce programs are capable of processing enormous data in parallel on large clusters of computation nodes. HDFS, Hadoop Distributed File System. HDFS takes care of the storage part of the Hadoop application. MapReduce application consumes data from HDFS. HDFS creates multiple replies of data blocks and distributes them on compute nodes in a cluster. This distribution enables reliable and extremely rapid computation. As we all know, Hadoop is a framework written in Java that utilizes a large cluster of commodity hardware to maintain and store big data. Hadoop works on MapReduce programming algorithm that was introduced by Google. Today, lots of big brand companies are using Hadoop in their organization to deal with big data. Example, Facebook, Yahoo, Netflix, eBay, etc. The Hadoop architecture mainly consists of four components. First one is MapReduce and HDFS, Hadoop Distributed File System, Yarn, yet another resource negotiator, common utilities or Hadoop Common. Let's understand the role of each one of this component in detail. MapReduce. MapReduce nothing but just like an algorithm or a data structure that is based on the Yarn framework. The major feature of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial processing is no more of any use. MapReduce has mainly two tasks which are divided into phase-wise. In first phase, map is utilized and in the second phase, map is utilized. Here we can see that the input is provided to the map function, then its output is used as an input to the reduce function, and after that we receive our final output. Let's understand what is map and reduce function does. As we can see that the input is provided to the map function. Now as we are using big data, then input is a set of data. The map function here breaks this data blocks into tuples that are nothing but a key value pairs. These key value pairs are now sent as input to the reduce function. The reduce function then combines this broken tuples or key value pair based on its key value and forms set of tuples and forms some operation like sorting, summation, type, job, etc., which is then sent to the final output node. Finally, the output is obtained. The data pre-processing is always done in reducer depending upon the business requirement of this industry. This is how first map and then reduce is utilized one by one. Now let's understand the map task and reduce task in detail. Map task. Record reader. The purpose of record reader is to break the records. It is responsible for providing key value pairs in a map function. The key value is its locational information and value is the data associated with. A map is nothing but a user defined function whose work is to process the tuple obtained from record reader. The map function either does not generate any key value pair or generate multiple pairs of these tuples. Combiner. Combiner is used for growing the data in the map workflow. It is similar to the local reducer. The intermediate key value that are generated in the map is combined with the help of this combiner. Using a combiner is not necessary as it is optional. Partitioner. Partitioner is responsible for fetching key value pairs generated in the mapper phase. The partitioner generates the shades corresponding to each reducer. Hash code of each key is also fetched by this partition. Then partition performs its hash code modules with the number of reducers. Reducer task. Shuffle and sort. The task of reducer starts with this step, the process in which the mapper generates the intermediate key value and transforms them to the reducer task is known as shuffling. Using the shuffling process, the system can sort the data using its key value. Once some of the mapping tasks are done, shuffling begins. That is why it is a faster process and does not wait for the completion of the task performed by mapper. Reduce. The main function or task of the reduce is to gather the tuple generated from the map and then perform some sorting and the aggregation sort of process on those key value depending on its key element. Output format. Once all the operations are performed, the key value pairs are written into the file with the help of the record writer. Each record in the new line and the key and value in a space separator manner. Yes. HDFS Hadoop Distributed File System is utilized for storage permission. It is mainly designed for working on commodity hardware devices, working on a distributed file system design. HDFS is designed in such a way that is believed more in sorting the data in a larger chunk of blocks rather than sorting small data blocks. HDFS in Hadoop provides fault tolerance and high availability to the storage layer and the other devices present in that Hadoop cluster. Data storage nodes in HDFS. Name node, master, data node as slave. Name node. Name node work as a master in a Hadoop cluster that guides the data node. Name node is mainly used for sorting the metadata, that is the data about the data. Metadata can be the transaction logs that keep track of the user's activity in a Hadoop cluster. Data node. Data node work as a slave. Data nodes are mainly utilized for storing the data in a Hadoop cluster. The number of data nodes can be from 1 to 500 or even more than that. The more number of data nodes, the Hadoop cluster will be able to store more data. So it is advised that the data node should have high storing capacity to store a large number. Data in HDFS is always stored in terms of blocks. So the single block of data is divided into multiple blocks of size 128 MB, which is default, and you can also change it manually. Let's understand this concept of breaking down of files in blocks with an example. Suppose you have uploaded a file of 400 MB to your HDFS. Then what happens in this file got divided into blocks of 128 MB plus 128 MB plus 128 MB plus 16 MB is equal to 400 MB size. Means 4 blocks are created each of 128 except the last one. Hadoop does not know or it does not care about what data is stored in these blocks, so it considers the final file block as a partial record as it does not have any idea regarding it. In the Linux file system, the size of a block is about 4 KB, which is very much less than the default size of file block in the Hadoop file system. Read or write operation in HDFS operate at the block level. Data files in HDFS are broken into block-sized chunks which are stored as independent units. Read operation in HDFS. Data read request is served by HDFS name node and data node. Let's call the reader as a client. Below diagram depicts file read operation in Hadoop. Read operation in Hadoop. A client initiate read request by calling openOf function method of file system object. It is an object of type distributed file system. This object connects to name node using RPC and gets metadata information such as the location of the block of the file. Please note that these addresses are of first few blocks of the file. In response to this metadata request, addresses of the data node having copy of the block is returned back. Once addresses of data nodes are received, an object of type fs data input stream is returned to the client. Fs data input stream contains dfs input stream which takes care of interaction with data node and name node. In step 4 shown in the above diagram, a client invokes readof method which causes dfs input stream to establish a connection with the first data node with the first block of file. Data is read in the form of streams wherein client invokes readof method repeatedly. This process of readof operation continues till it reaches the end of block. Once the end of block is reached, DFS input stream closes the connection and moves on to locate the next data node for the next block. Once a client has done with the reading, it calls a close-off method. Write function in HDFS. In this section, we will understand how data is written into HDFS through files. Write operation in HDFS. A client initiates write operation by calling createOf method of distributed file system object which creates a new file. Step number 1 in the above diagram. Distributed file system object connects to the name node using RPC call and initiates a file creation. However, this file creates operation does not associate with blocks with the file. It is responsibility of name node to verify that the file which is being created does not exist already and a client has correct permission to create a new file. If a file already exists or client does not have sufficient permission to create a new file, then IO exception is thrown to the client. Otherwise, the operation succeeds and a new record for the file is created by the name node. Once a new record is name node is created, an object of type fs data output stream is returned to the client. A client uses it to write data into the HDFS. Data write method is invoked. FS data output stream contains DFS output stream object which looks after communication with data nodes and name nodes. While the client continues writing data, DFS output stream continues creating packets with the data. These packages are encoded in a queue which is called data as queue. There is one more component called data stream which consumes this data queue. Data streamer also asks name node for allocation of new block, thereby picking desirable data nodes to be used for replication. Now the process of replication starts by creating a pipeline using data nodes. In our cases, we have chosen a replication level of 3 and hence there are 3 data nodes in the pipeline. The data streamer pours packets into the first data node in the pipeline. Every data node in a pipeline stores packet received by it and forwards the same to the second data node in a pipeline. Another queue, ask queue, is maintained by DFS outstream to store packets which are waiting for acknowledgement from data nodes. Once acknowledgement for a packet in the queue is received from all data nodes in the pipeline, it is removed from the ACK queue. In the event of any data node failure, packets from this queue are used to reinitiate the operation. After a client is done with the writing data, it calls a close off method. Step 9 in the diagram, call to close off, results in flushing remaining data packets to the pipeline followed by waiting for acknowledgement. Once a final acknowledgement is received, name node is contacted to tell it that the file write operation is complete. Yarn, yet another resource negotiator. Yarn is a framework on which MapReduce works. Yarn performs two operations that are job scheduling and resource management. The purpose of job scheduler is to divide big tasks into smaller jobs so that each job can assign to various slaves in a Hadoop cluster and processing can be minimized. Job scheduler also keeps track of which job is important, which job has more priority, dependency between the jobs and all other information like job timing, etc. And the use of resources management is to manage all the resources that are made available for running a Hadoop cluster. Features of Yarn: multi-tenancy, scalability, cluster utilization, compatibility. Hadoop Common or Hadoop Common Utilities. Hadoop Common or Common Utilities are nothing but our Java library and Java files, or we can say the JavaScript that we need for all the other components present in the Hadoop cluster. These utilities are used by HDFS, Yarn and MapReduce for running the cluster. Hadoop Common verifies the hardware failure in the Hadoop cluster is common to so it needs to be solved automatically in software by Hadoop framework. Topology of the network affects the performance of the Hadoop cluster. When the size of the Hadoop cluster grows, in addition to the performance, one also need to care about the high availability and handling of features. In order to achieve this, Hadoop clusters formation make use of network topology. Typically, network bandwidth is an important factor to consider while forming any network. However, as measuring bandwidth could be difficult in Hadoop, a network is presented as a tree and distance between nodes of this tree, number of hops, is considered as an important factor in the formation of Hadoop cluster. Here are the distance between two nodes is equal to sum of their distance to their closest common ancestor. Hadoop cluster consists of a data center, the rack and the node which actually executes job. Here data center consists of rack and rack consists of nodes. Network bandwidth available to process varies depending upon the location of the processes. That is, the bandwidth available become lesser as we go away from processes on the same node, different nodes on the same rack, nodes on different racks of the same data center, nodes in different data center. Features of Hadoop: open source, it is highly scalable cluster, fault tolerance is available, high availability is provided, cost effectiveness, Hadoop provided flexibility, easy to use. Thank you.